Hi, I'm Tim Hoffman, and this is Micah Croff. And what I'd like to talk to you about today is a problem that Micah and I have struggled with for probably about a year when we were at Twitter, and something that we ran into when previous employers. And ultimately what it comes down to is some limitations in how you can deal with failures with BGP. And a lot of the problem is, here we go, is how do we deal with network failures today? So ultimately, today we have ISIS, we have BGP, a transport link fails, and we end up in a position where we move routes around via ISIS. BGP sessions go down facing a transit provider, and we're in a position where we move to other transit links or peering links. Or we have a CDN cache that might go down, we might be running BGP to it or some health checks, and we're in a position where we can move traffic around via those. Routing protocols and health checks do all this really well in certain circumstances. The challenge you run into is when this isn't enough. So what happens if there's no way to detect a black hole condition? So all of these situations have been seen by either Micah, myself, Bruce, who is in the audience somewhere, or Nick from Juniper, or there's a guy called Ben who's been helping with this as well, Ben Dale in Australia. So first example is, let's say I'm a CDN provider and I have a single transit provider in, say, New Zealand, because not a lot of choice there, and I'm on an internet exchange. Now, my CDN node in my POP is advertising a bunch of BGP routes to my router, and then I'm advertising that onwards to an internet exchange. So if my transit provider fails, I'm still advertising these routes out to the internet exchange, and I'm in a position where this user is coming to me to get this traffic, and I'm unable to do origin requests, which puts me in a position where effectively I'm going to black hole their requests. So in this scenario, obviously there are things you could do on the CDN server. There are ways to deal with this at other layers, but from a network layer, we have no way on the router to identify this problem and say, actually, I need to stop. And things that you could do are, I've seen in previous lives, counting the size of the routing table and taking a router out of service based on that. But then you're in a position where, let's say a tier 1 has an issue, you've actually got a very real danger of all of your routers withdrawing the routes at once. The next example is if a service node is isolated from the backbone, say basically the same scenario, except that rather than having a transit-based backhaul network, you're using your own backhaul. And in Brazil, at Twitter, we've found it's reasonably common that you lose multiple links at once because of the nature of that country. So you end up in a position whereby you now have no connectivity back. And again, the user is coming in across the internet exchange to a CDN server, which is advertising its route still to a router, and you're black holing your traffic. And the next thing is, what if actual black holing action happens across router hardware? So for instance, everyone at some point has run into some sort of horrible bug where a router has decided just to discard traffic but to keep the routing protocol up. And if you end up in that position, how do we actually tie some traffic, some actual real-world traffic to the routing protocols? And the fact that Junos RPM or Cisco IP-SLA isn't able to be directly tied to routing protocol actions yet in 2016 is absolutely terrible. So for all of these problems, how do we deal with this and how do we actually tie this together? And there's kind of a fourth problem that we've identified here, which is slightly different. But let's say we have a lag facing an internet exchange, and that internet exchange is it's a 50 gig lag, and we're doing 40 gig of traffic over it. Now again, just picking on Brazil because it's a really interesting example, there are some networks that we really want to be able to serve in Brazil, and some that we're actually a bit more okay moving out to Miami, depending on the connectivity of their transit up to the United States. So if we lost a couple of members on this link, really we want to be able to shed a small amount of traffic rather than just using minimum links. Because if we use minimum links, we will end up in a position where we don't have packet loss, but we won't end up in a position whereby we're actually able to keep a smaller amount of traffic going. ideally, we'd be able to trigger a couple of AS path prepends to shared requests facing specific networks, and then tune that traffic down to the point where we're actually able to serve 25, 30 gig across it. So these are some of the problems we've run into, and I guess what we ended up in a position of is that Micah and I at Twitter were sitting there and trying to work out how do we get to a point where network-wise we can tell nodes to take themselves out of service if they don't have connectivity back to a data center or back to an origin. And how can we evaluate whether it has connectivity to multiple origins or just one origin data center? And these sort of problems started, and we started going, well, actually, we need some way of evaluating the state of our routing table. And it's going to be unrelated routes. And what we started doing is using the rudimentary conditional routing functionality that we have in, say, a Juniper router or an ASR, and started anycasting a /32 from all of our data centers. All of our POPs then started examining this and saying, if I can see this one /32, I'm in service. Otherwise, I remove myself from service. Now, the problem is this, I'd liken this to a blunt hammer, and that we were in a position where, while this did the job, we had a single /32, we had no way of incrementally starting to say, do I actually have good connectivity back to my origin? And what we kind of looked at was, there's got to be a better way of doing this. There's got to be a way where we can evaluate in a more granular manner, do I have access to one of my origin data centers or 3 of my origin data centers? And I will add prepends or I will modify something to reflect this. So obviously the real solution here is to automate. And if you're a network like Twitter or anyone our size, you're going to have the resource and you will have automated to the point where you can say that there is some arbitrary check that is happening. And if that check fails, you're going to take some action. And in this case, we might say we're going to log onto the router or monitor for SNMP traps or do some sort of check every X minutes. We're going to ask it how many ISAS neighbors it has, for example. And then we're going to say, right, I have no ISAS neighbors. This is a bad state. I'm going to take you out of service. And I'm going to modify some configuration to remove this router from being in service. Now, this is all well and good. But ultimately, if your router is in service and your out-of-band circuit is your router has no backhaul and your out-of-band is not working either, which is something that does happen in some of these more remote locations in the world, then you have no way of touching your router. You would not want to be in a position where you have to tell the local operator to go and remove the power from your rack. I've done this before. And this was the case where 2 backhaul circuits were out of service, and we were in a position where the out-of-band was also out of service because the out-of-band, as it turned out, relied on another operator that used the same 2 backhaul paths. This wasn't at Twitter, by the way. Or if you don't have out-of-band. Now, if you do not have out-of-band, you're fairly stupid. But ultimately, some people are unable to get it in some places. An example is that in Dubai it's very difficult to get an out-of-band circuit delivered into the part of Dubai that you can build a data center in that is not subject to all their local regulations. They have a free trade zone there, and supplying an internet connection into that free trade zone is harder than you might think. Or, let's face it, if you're a if you've got 2 people on your network operations staff, you might not have the resourcing to build an automated remediation system. So suddenly we're now in a position where we're having to page a human. And at 2 a.m., the human does not think straight, and it takes 15 minutes to wake up and then 10 minutes to mitigate. So we need a way to do this at the routing layer. And the real thing we've started to think about is, how could we solve this? So obviously, being in a position to do a single conditional route and start to depend on one route existing across your network, and there's one configuration change you could make to hose that route and take all of your routers out of service. That doesn't work. And looking at some sort of arbitrary state, and you could write some JSLACs, as I talked about, or you could do something on on the BSD of the Juniper or the Linux of the ASR. You can do all these things, but they're just kind of hacky. And ultimately, we want to be able to do things like, do I have access to 5 different tier 1s routes? Can I ICMP these 5 hosts rather than this one metric we might count? Saying if I can't see Microsoft, I'm going to take it out of service means that this works until Microsoft comes off the internet. However unlikely, that will happen one day. And I think this is the thing, we just have not solved this, and we haven't got ourselves into a position where we can examine the state of our routing table, where we can ICMP to a bunch of hosts, and then tie that to routing decisions, and tie it to whether a host is healthy and in service. And in 2016, I really, really believe that we can do a lot better. So one thing that Micah and I looked at when we first started talking about this, and then we involved Ben and Nick and Bruce to start forming a working group around this, is that we looked at how VRRP worked. VRRP seemed like the closest thing to a protocol that would track variables, weight them in a priority value, and then take actions. Now, VRRP, as we all know, can only have an active or a passive state. You can measure a prefix in a routing table. You can measure the physical state of an interface. You can then take some actions on it. It doesn't do exactly what we want, but it leads to something, which is that we have some sort of prioritization metric and some way to weight against it. And I think VRRP is where we can really learn something here, in that we can look at the ability to have some sort of weighted conditional bucket and put ourselves in a position where we can start to say, should I be in service, or should I reduce my priority to try and shift, to try and signal that I might not be as good as my neighbor router. And now Micah is going to come up and talk about the new method of conditional routing that we propose.
Thanks, Tim. Good morning, everyone. As Tim said, I'm Micah Croff. I work at GitHub. And one of the things that I wanted to talk about before I get into how we propose solving this problem. So when Tim and I first sat down and we were first discussing how we should solve this problem, we came to a very clear decision early on, and that is no new routing protocols and no extensions to existing protocols. We must leverage what is pre-existing today in BGP, ISIS, and OSPF. So local pref, manipulating local pref, AS path prepending, or applying neighbor policy in BGP, manipulating metrics and costs in ISIS, or setting the overload bit. So with weighted conditional routing, how well, from a router's perspective, I can determine how well am I connected to the backbone or to my data centers. And I can make decisions based on these conditions, whether I take a router out of service or I shed traffic away from this router. So the concept that Tim mentioned and alluded to is buckets. Not a new concept, it's simply a named variable. You can have any number of named variables. A variable would start at a value of 0. The greater the value, the better connected I am. You can then reference these values from within policy and make a decision based on them. There we go. So tests. How many routes do I have matching a particular policy? Or perhaps maybe I want to determine how many routes I have in a given table. Or the number of routes that I'm learning from a particular neighbor and make a decision based on that. We also came up with the concept of a percentage of BGP peers that are established in a particular group. So if you have an iBGP peer or a full mesh, maybe you want to ensure that you have 90 or 95% of your BGP sessions established before a router goes into service. So an example of one of these tests might be, as Tim mentioned, how many members do I have in this lag? For each member in a lag, say I have a lag facing AM6, each member will add an additional 10 points to this bucket value, and I can make a decision based on that. Or can I ICMP across my backbone using IPSLA or RPM to my data center? Or can I ICMP and make a connection to Google or Microsoft or Twitter, and then make a decision based on that? So with these test results, I have a test A, and I have a bucket, say red, If test A passes, red plus gets 100. Or test B, then green plus gets 200. And then if red falls below 100, I take an action. And then if green falls below 200, I can take another action based on this. So let's talk about actions. So in this example, green has fallen below my threshold value. But instead of taking a router out of service, I just simply want to shed traffic using AS path prepending. So I can apply this policy then to a neighbor or a collection of neighbors or even at a group level to shed traffic away. Now in this case, we're going to overload the IGP, in this case ISIS. We have hit a catastrophic failure and red has fallen below the threshold of 5 and I need to shed traffic immediately away from this router. So with this conditional overload, I value, my bucket falls below 5 and I immediately shed traffic. So in discussing this and working on this for roughly the last 10 months, Tim and I, and in conjunction with Bruce and Nick and Ben, Cisco and Juniper are both actively involved. What we would like to do is solicit the NANOG community for feedback. So we've come up with a lot of tests and use cases for our environments and what we've seen in our careers. But what would make sense in your environment? What have you seen that we haven't thought of? So these are some of these tests and actions that we have come up with that we think would be useful. But what did we miss? What would be useful in your environment that we could also integrate? So for example, we talked about number of established BGP peers, active prefixes in a routing table, or the number of next hops. But there's something else out there that we just haven't thought of. Another question that we wanted to solicit or get feedback on is how do we prevent these cascading failures? As Tim mentioned with the option of running scripts on a particular box, you have the potential to create a cascading failure when a tier 1 falls off the internet. Ideally, we would leave this up to the user and allow the end user to come up with the best solution for their particular environment. And we would like to see, rather than taking a router out of service as the worst case, maybe shedding traffic for a collection of neighbors or a collection of BGP peers. But what else could we do to prevent these cascading failures? Also another, in tossing this back around, what makes more sense? A percentage or a hard value? So in an example of, if I have, again, I'll use the AM6 example, 10 members in a lag, do I want to drop below a value if I lose 5 or 50%? What is more preferred in the configuration? So where we have been and where we're going, again, we've actively been working with Juniper and Cisco. We've been working on this roughly 10 months. We have commitments from both Juniper and Cisco to implement this in their platforms in the coming releases. So we've been working on the working group. We're presenting it today to NANOG to solicit feedback. Once we get feedback, we're going to submit it as an IETF draft and RFC and get, as I said, both Juniper and Cisco, and we'd love other folks to jump on the wagon for implementing this technology. So please reach out. Give us feedback, stop us in the hall. We'd love to talk about this, or if you just want a GitHub sticker, I have a whole bag full of them. But thank you, and I will turn it over to Tim for open questions.
You'll join me for that. So I guess we're really seeking your feedback, so if there's any questions or feedback about this now, we would love that.
Matt Petak, Yahoo. This sounds like great work. We're doing some similar stuff internally, but right now everything is still very much in the vendor specific, okay, we can code this up on this vendor, it's not broadly applicable. Are you asking for more broadly vendors to get together and say, let's define a language? Do you want us as operators to speak up and say, this is what we would like you to develop in this? What level of feedback and support are you looking for right now? Can you clarify?
We really want operators to come forward and tell us what should be in here. And I think the aim is to define an RFC which calls out a preferred way vendors should implement this. Because as we know, when we've got three vendors doing it different ways, it helps no one. So the idea is to define a standard that we can all follow. And while we haven't been engaging with all of the vendors yet, both Nick from Juniper and Bruce from Cisco have been actively working with us in the working group. So we feel there's a great enough support from Juniper and Cisco to get to the point we can get a standardized implementation.
Gotcha, thank you.
Yeah, and yeah, your thoughts will be much appreciated.
Tony Tauber, Comcast. So in the IETF context, what working group would you see it falling into?
So, speaking for Nick, who has a lot more experience in this will be the first working group, first paper that Micah and I have been involved in presenting. The intent would be to present this as a best practices RFC. So, as the way we should implement this. And I am the first to admit I will be learning quite a bit as we go through this process. And we would love any assistance and guidance from anyone that they can provide.
Yeah, to me it seems like maybe the GROW, Global Routing Operations Working Group, would probably be kind of the closest fit. And you might think about something like a use case document and then a solution document. That kind of thing.
Absolutely. So one thing that we've been working on is we actually have this all modeled in a VMX environment with JSLAX. So Ben Dale has actually written all of this conditional routing functionality into there. So when we present, well, we didn't want to do a live demo here. When we present this to the IETF, we can actually pass references to some GitHub links to topologies and configurations and the JSLAX to actually allow people to implement it at home and play around with it.
Cool.
Yeah. Thank you for the advice.
Hi, Brandon Bennett with Facebook. It seemed like a lot of the conditions you were talking about were very network focused.
Yeah.
And obviously there's two sides of the coin here, which is the application as well.
Yep.
Is there any thoughts or any plans on trying to have like an API or some way for an application to affect this conditional routing?
That's a really good idea. Can you email through and let's discuss that a whole lot more, because I think that would be a great way to improve this.
Okay, thanks.
Yeah.
Hi, Patrick Elmore, Market Group. I like the idea, and I don't want to be down on it or anything, but the thing
constructive criticism is also awesome, so don't feel bad about it.
So having done a little bit of work on, for instance, having CDN servers in strange places that may not be able to reach origin servers in the past, and looking at sort of exactly this, the thing that I always came back to is that, and this has been a principle for literally decades, is that you want smart edges and dumb cores. And this is a violent breaking of that idea. And now we have multiple places where we have to look for what's going on. The router knows what the router knows. The application knows what the application knows. And so it just, from a higher level, and maybe things have gone past what I think of, and that's entirely possible, but from a higher level, I just think the intelligence should be on the server, and that we shouldn't have the routers making these kind of decisions, because the failure cases and the corner cases that this could back us into are both legion and terrifying.
Yeah, so we're definitely giving, if this is implemented, it gives everyone a lot of rope to do good things and to hang themselves with. That is for sure. I agree there's a use case for a CDN server to inspect its origin and decide whether it's going to send to BGP announcements. But perhaps something we didn't cover in the talk, which we've also experienced in the past, is you have an aggregate route on a local router being triggered by an interface route. There are non-CDN specific use cases here, or non-application server specific use cases as well. So, and I think the key here is to give it a set of tools that operators can decide what they want to do with. From a Twitter use case, which I can speak to, I think our aim is that we definitely want to be in a position where application servers will withdraw routes under certain conditions, but also to have the network devices monitoring it. And I totally hear you that that is a violation of that principle, but I think having that functionality there and having that safeguard can be really important, because there is nothing worse than black holing behavior in your network.
Okay, it's not like we couldn't have hung ourselves before, so
yeah,
a new piece of rope is fine.
Yeah. Thank you very much.